Today in the workshop, we're exploring Raspberry Pi remote access. You'll see how to remotely access your Raspberry Pi using SSH, VNC, and Raspberry Pi Connect. We'll also learn about TCP/IP, the networking protocols used by the Raspberry Pi. So get rid of the mouse, keyboard, and screen, and welcome to the workshop. Well, hello and welcome to the workshop, or I should say welcome back to the workshop. It's been a while since I created a video, and if you'd like to know the reason for that, you can check out the short clip that I posted last week about the situation outside of the workshop. And because I've been outside of the workshop, this seemed like an appropriate video to get back at things with, because today's video is about remote access, specifically remote access using the Raspberry Pi. Now, the Raspberry Pi microcomputer has been around for about 11 years, and in those 11 years it's become a favorite among makers and hobbyists and students, and people have built thousands of different projects with it, and not all of those projects require a mouse, keyboard, and screen. There are many Raspberry Pi projects that run standalone, things that run in your network to keep commercials off your web browser, or a fan that is controlled in your attic with a temperature sensor. In those cases, it's really kind of a drag to have to add a keyboard, mouse, and screen just to occasionally update the Pi or to reboot it. And so remote access is a great thing to use. Now, I'm going to show you two different types of remote access. Remote access that just gives you a terminal screen, which in many cases is all you need to start a Python program or to reboot or update the Pi. And also remote access that can give you the full GUI experience with a mouse and a keyboard and everything that you need, just as if you were sitting at the Pi itself. And we're going to look at three different products to do that, all of them from Raspberry Pi itself. But before we get into those products, I think it would be a good idea to learn a little bit about how a Raspberry Pi works on a local area network, because that's the way that we're going to be doing remote access. So let's take a quick look at networking and remote access with the Raspberry Pi. Today we'll be examining three remote access methods for the Raspberry Pi: SSH, VNC, and Raspberry Pi Connect. All of these methods work upon TCP/IP. These are the two protocols that the Internet and your local area network are based upon. TCP is Transmission Control Protocol, and it's responsible for delivery and reliability of the packets on a network. IP is the Internet Protocol, and it's responsible for the routing and addressing of those packets. You can think of TCP/IP as a flight on an airplane, where TCP are your stewards who make sure that everybody is comfortable on the plane, and IP are the pilots making sure the plane gets to where it is going. Let's take a look at a packet traveling from one workstation to another. On the originating workstation, TCP is responsible for packaging the data, whereas IP is responsible for addressing it. When the packet reaches the router, TCP is responsibility for checking the reliability of the data, whereas IP performs the routing. On the destination, TCP is responsible for the delivery of the packet, whereas IP is responsible for the addressing, making sure the packet went to its actual destination. There are two forms of TCP/IP, IP version 4 and IP version 6. IP version 4 is the most popular version of TCP/IP. It's a 32-bit protocol, however it is now running out of addresses. IP version 6 improves the performance and security. It's a 128-bit protocol, however the entire infrastructure does not yet support it, but this is changing very rapidly. To connect to a TCP/IP network, a Raspberry Pi or any other workstation requires three parameters: a unique IP address, the gateway, which is the destination for non-local traffic, and a subnet mask to define the local area network. Let's see how this works. We can take a look at our IP address and our subnet mask. This will make more sense if we convert it to binary. When converted to binary, you can see how the subnet mask is applied to the IP address to determine what part of the address is the network address and what part is the host or local client address. The subnet mask defines the boundaries of this local IP network. It's also applied to the destination IP address. If the destination is in the local network, then packets are sent directly to it. If it's not on the local network, then packets are sent to the gateway address. Here's an example of this configuration. In this configuration, we have a router, we have 2 local machines, and a web server on the internet. To send the packet from one workstation to the other, the subnet mask is applied. It's determined that this is the local network, and therefore there's no need to even go through the router. When the destination is on the internet, however, the subnet mask will show that you need to use the gateway, in this case the router. The packet will go through the router and be passed out to the web server on the internet. When you have Wi-Fi, you'll have a different subnet for the Wi-Fi, so you'll actually have 2 different local area networks. It's also possible that your configuration might have additional local area networks, such as a guest network or an IoT network. These will all be different subnets. In order to transfer data between subnets, your router will make use of an internal routing table. This defines the routes between the subnets. If you add additional equipment, you might need to add static routes for those external networks, otherwise they'll be unreachable from your local area network. You might be wondering about those 192.168 addresses. These are defined as private IP networks. This selection of addresses will never appear on the public internet. It's what's called a Class C network with 8 bits for the host and 24 bits for the network. Your router has 2 addresses, the one on the local area network and an address on the public internet. You can use port forwarding, which is sometimes called a virtual server, to route external traffic to a private network. If you want to use this with the remote access methods we're working with today, you'll need to open up port 22 for SSH or port 5900 for VNC. Raspberry Pi Connect does not apply here. Your router will have a number of different configuration screens for setting up static networks and routes. In addition, your router can display the DHCP client list, which lists the IP address of all the devices on your network. Very useful when you're performing these experiments. So get to know how to use your router configuration panel, and let's go and configure some Raspberry Pi remote access. Now here's a small sampling of Raspberry Pi microcomputer boards that you could use for these experiments. These are some of the more popular ones, but there are certainly other boards as well, such as the Raspberry Pi 400, which is an all-in-one computer system based upon the Raspberry Pi 4. Now, starting here, we've got a Raspberry Pi 0W, and this only connects to the network using Wi-Fi, whereas these other 3 boards can use Wi-Fi or Ethernet. And this is a Pi 3, a Pi 4, and a Pi 5. I've also got the active cooler for the Raspberry Pi 5 over here. You're going to need some form of cooling on this board because it does run quite warm even when it is idling. Now, if you're going to be buying a brand new Raspberry Pi, I would recommend buying the Raspberry Pi 5 as it has some advanced hardware features and supports all the functionality of the newest Raspberry Pi operating system called Bookworm. But they've just updated Bookworm to run with all of the Raspberry Pi boards, and so really any of these boards would be a good selection for your experiments with remote access and the Raspberry Pi. Now for the first 2 remote access methods that we'll be using today, you'll need to know the IP address of your Raspberry Pi. Bear in mind that if you have Wi-Fi and a local area network connection, you'll have 2 IP addresses, and you can very easily determine that just by hovering over the network icon over here. And you will get this display. I hope you can see that. It's got both my wireless network connection and my Ethernet network connection IP addresses displayed. Now another way you can do that is from the command line at the terminal. So if you go into the terminal and do a hostname command with a /i parameter, you will get the 2 IP addresses. However, it doesn't distinguish which one is which. I happen to know that the .1120 is the one on my local area network, whereas the .39181 is on my Wi-Fi network. But if you didn't know that, you'd probably be better off just by hovering. But at any rate, write those addresses down because you're going to need it for the first 2 access methods. Now, the first method of remote access that we're going to look at today is called SSH, or Secure Shell. SSH remote access will give you access to the terminal within the Raspberry Pi. You won't get the complete GUI, but in many cases, this is all you need. If you want to start a Python program, if you want to do some updates, if you want to reboot the Pi, a terminal is all that you require. Now, SSH will require a client on your side, and in many cases, the client is already on your computer because the client is just another terminal. So let's go and see how easy it is to set up and use SSH with the Raspberry Pi. SSH, or Secure Shell, is a method of remotely accessing a terminal session on a Raspberry Pi. SSH establishes a secure channel using TCP port 22, so this is the port that you'll need to open if you're configuring a router to pass SSH. It employs public key cryptography to keep your data safe. SSH is a tunneling protocol, and a tunneling protocol keeps the data hidden and can also traverse networks that normal TCP protocols cannot. In order to use SSH, you'll require a terminal application. Using SSH on the Raspberry Pi is pretty simple. You just enable SSH on the Pi and then use a terminal. If you're using Linux, you could use the standard Linux terminal. Mac users can also use the built-in terminal. Microsoft does provide a Windows terminal that you can use with SSH. It's not installed in Windows by default, but it's a free download from the Microsoft Store. Another free download and very popular terminal is PuTTY, which runs under Windows and can also run under Linux using Wine. Now, setting up SSH is very simple. You can do it just from your Raspberry Pi configuration screen, which you'll get to by hitting the Raspberry at the top here, and then go into Preferences, and then go into Raspberry Pi Configuration. Under the Configuration screen, go into the Interfaces tab, and you will see a number of different options here, and SSH is the first one. Just go and enable that, click OK, and it's done. It's as simple as that. And now we're ready to use SSH on the Raspberry Pi. Now, another method of enabling SSH in the Raspberry Pi is to do it using the Raspberry Pi Imager tool when you are first creating an image to boot from. So you'll go through the normal options of choosing your device. I'm going to choose a Pi 5. Choose the operating system, and I'm always going to pick the most recent one, which is Bookworm in this case. And choose the storage device, and here's my storage device. Now I'll click on Next, and I'll be offered the option to apply OS customization settings. I'm going to go into Edit Settings. Now, in the general settings, you can set your host name, you can set the username and password, etc., etc. But what I want to show you is in Services, you can enable SSH. And if you do this, it'll enable it with password authentication, which is a standard feature. So save that. You might want to enable edit some of the things in the first page as well. And then this will be a method of having SSH already enabled on a Raspberry Pi when you first boot it up. Now, to use SSH from a remote computer, you're going to need a terminal application, and of course there are different terminal applications for different operating systems. In this particular case, I'm in Ubuntu Linux, and I'm using the built-in terminal. I've opened up the terminal, and I've typed in SSH, and then my username, which in my case is DroneBot Workshop. Of course, yours will be different. And then an ampersand sign, and then the IP address of the Raspberry Pi. And so I'm going to hit Enter. And I am going to get this message about the authenticity of the host. And this has to do with a security key. You're only going to need to answer this once. And it says, are you sure you want to continue connecting? And I'm going to type in yes. And it's going to ask me for my password. And I'm there. And now if I do a command like ls to display file names, I can see that I'm actually on the Raspberry Pi right now inside my session. And so this is very simple, and it's a very simple method of gaining remote access to a Raspberry Pi if all that you need is command line access. If you need something more than command line access, however, we can look at another remote access method. Now, in some cases, terminal access to the Pi isn't sufficient. You need to get the entire GUI screen, and the next access method will give you exactly that. VNC, or Virtual Network Computing, allows you to get remote access to a complete terminal screen. Now, you're going to need a VNC client on your end, and there are different clients available for Windows, for Linux, and for Mac, and so you'll need to install that on your computer to use VNC. Otherwise, setting up VNC on the Pi is pretty well as easy as setting up SSH was. So let's go and take a look at how we set up and use VNC on the Raspberry Pi. VNC, or Virtual Network Computing, is a method of establishing a remote desktop connection with the Raspberry Pi. VNC employs RFB protocol and uses TCP port 5900. RFB, or Remote Frame Buffer Protocol, is a method of sending full-frame video over TCP. While VNC itself does not provide security, the Raspberry Pi implementation adds a security certificate. VNC establishes a connection with a GUI and accepts a mouse and keyboard input. In order to use VNC, you'll require a VNC client. Setting up VNC on the Raspberry Pi is pretty easy. You just enable the VNC, and on the remote end you can use a client such as Tiger VNC or Real VNC. To enable VNC, you'll do exactly the same thing you did with SSH. Open the Raspberry Pi configuration screen. You'll notice an option for VNC here. You can click on that and say OK. And now we have VNC enabled on our Raspberry Pi. Now, in order to use VNC, you're going to need a VNC client on your computer, and there are a number of different VNC clients available. I'm using a free open source client called Tiger VNC, and it's the one that Raspberry Pi recommends that you use. It's available for a number of different operating systems, and I'm using it right now under Microsoft Windows. Now, when you start Tiger VNC, you'll get a dialog box, and in the box you'll need to put in the IP address of your VNC server. So that's the IP address of the Raspberry Pi. You'll also want to go into Options, and in Options under Input, do what I've done over here. Click Show Dot when no cursor. That'll make the display a lot better on the Pi. Now I'm going to connect to the remote server, and when I connect I get a username and password box. Now the first time you do this, you'll likely get a couple of boxes about a security certificate. Just accept the certificate and you won't get it again. This is your username and password on the Raspberry Pi. And we'll say OK to that. And we are on our Raspberry Pi screen. As you can see, this is the desktop on our Pi, and we can pretty well do anything here that we could do on the Raspberry Pi desktop. So if you need a full desktop GUI on a machine on your network, VNC is a great way to go. Just set it up, get a VNC client, and you're on your way. Now, the third and final remote access product that we are going to look at is also from Raspberry Pi and is currently in beta, and it's a very active beta. In fact, I've refilmed this a total of 3 different times because every time I think I have the feature set of this down, they keep changing it and adding new features, and things that I told you in the video that you couldn't do, you can actually do right now. So there's a good chance that I'm going to tell you about some limitations in this product today that don't exist by the time you look at the video, but I give up. I have to make the video, and this is actually a pretty amazing product. It's called Raspberry Pi Connect, and Raspberry Pi Connect is available in 2 different versions. The full-fledged Connect, which will give you a remote desktop just like VNC, and a smaller Connect Lite, which will give you just a terminal session just like SSH did. The beauty of Raspberry Pi Connect is you don't need to know anything about your network or about your IP address. Raspberry Pi Connect works in conjunction with a Raspberry Pi server, and you will need a Raspberry Pi account, which you can get for free. And so get yourself a Raspberry Pi account, and let me show you how you can use Raspberry Pi Connect. Raspberry Pi Connect is a remote access solution that comes in 2 different flavors, Connect and Connect Lite. With Raspberry Pi Connect, you can connect to a Raspberry Pi anywhere in the world without knowing its IP address. Raspberry Pi Connect is based upon a Pi Connect server. Currently, there is only one of these servers, and that's in London, England. To use Raspberry Pi Connect, you enable Pi Connect on your Raspberry Pi, and then register your Pi with the Raspberry Pi Connect server. On the remote client, you use your web browser to go to the Connect dashboard, and you select the dashboard from the server. Raspberry Pi Connect will try to establish a local connection on your local area network to the Raspberry Pi. But if that's not possible, it'll use the Pi server as a relay. The product is available in two different flavors, Pi Connect and Pi Connect Lite. Pi Connect provides the full desktop GUI experience and requires a web browser as a client. Pi Connect Lite only provides a terminal, and it's also used with a web browser. So let's go and set up Raspberry Pi Connect. If you're using the latest release of Bookworm, then the installation of Raspberry Pi Connect is very simple. Again, you'll go into your Raspberry Pi configuration screen, and you may just find that Connect is already enabled. If you haven't got it enabled, you can, of course, just throw the switch and hit the OK button in order to enable Raspberry Pi Connect. Now, if you're using an earlier version of Bookworm, you can install Connect at the command line, and I have instructions for that on the article that accompanies this video on the DroneBot Workshop.com website. Now, in order to complete the installation of Raspberry Pi Connect, you're going to have to connect it to the Raspberry Pi server and register the board. And you can do this using the icon at the top of the GUI that is for Raspberry Pi Connect. So just click on this and do sign in, and it'll open the web browser. Now, I'm already signed in, so I've got my ID here. Otherwise, you'll have your login credentials to present. And you're going to have to name the device that we're adding. So let's just call this, we'll create the device and sign in, and it says it's successful. So now this device has been added to my Raspberry Pi list. And if you look at the devices on Connect, I now have this, so I can go to another computer and connect to this Raspberry Pi. So I'm on my computer, and I'm on the Raspberry Pi Connect screen, and I can see the remote Raspberry Pi I have, and it says it has both screen sharing and remote shell. So if I do connect via, I have two choices, screen sharing and remote shell. Let's see what screen sharing looks like. Now this will take a moment to make a connection. It goes out to the Raspberry Pi server in London and establishes the connection, and there we go. And we've got my Raspberry Pi, and I can pretty well do whatever I want with it as if I was right at the desktop, and all I'm using is a web browser. So this is really convenient. You could do this from your tablet, you could do this from your computer, probably even from your phone. Let's close this one and look at the remote shell, and we do connect via, and we'll do a remote shell. Once again, we've got to go out to the Pi server and make the connection. This can sometimes take a while. And there we go, we're on the remote shell. And we can work on it just as if we were on the Raspberry Pi. So Raspberry Pi Connect is a really great way to do a remote connection to a Raspberry Pi. You don't need to know your IP address. It can work from inside your network. It can work from outside your network. It's simply a really great product, and I urge you to experiment with it if you've got remote Raspberry Pi connection needs. Now, as I said, Raspberry Pi Connect is a product that is still in consistent flux, and they keep adding new features and removing limitations from it. And so I would suggest that you check out the Raspberry Pi Connect website for the official documentation as to what it can do right now. There have been rumors that Raspberry Pi Connect may be a product that you will need to pay for in the future because of the fact that it connects to a remote server. Right now, there's only one remote server in London, but they may change that, and they may need to charge a cost to defray the cost of adding the servers. That is just a rumor right now. Another rumor is that they're going to add a file transfer capability to it, although you could do that right now using FTP or SFTP. So again, I would urge you to check the official Raspberry Pi documentation. Now you'll find a link to that documentation and a number of other useful resources on the article that accompanies this video on the DroneBotWorkshop.com website. And there's a link to that article right below the video. While you're on the article, if you haven't yet, please consider signing up for my newsletter. It's not a sales letter, it's just my way of letting you know what goes on here in the workshop and lately what's been going on outside of the workshop. Also, if you're in a signing up mood, the DroneBot Workshop forums is a great place to go when you want to talk to like-minded individuals about your electronics projects. It is free to sign up for the forum as well. And another thing that is of course free is to subscribe subscribe to the YouTube channel. I love getting new subscribers and would love to make you the next one. And all you need to do is click on that red subscribe button. And if you also click the bell notifications, you will get notified every time I make a new video, assuming, of course, that you've enabled notifications for YouTube on your web browser. And so until the next time we get together, which I hope will be very soon, please take good care of yourself. Please stay safe out there, and I'll see you soon here in the DroneBot workshop. Goodbye for now.